Okay, so this will be the last class for this week, and we will kind of like wrap up the chapter. So your test will be on Thursday, and it will cover everything that we've covered so far, including today's class. And again, this is more of a review than anything. So we're going to talk about domain and range again. But this time, as you can see, you know, I have many examples to kind of like get my point across. So let's work this out. So when the points are given to you, kind of like in question one, so I've circled the questions that I'm going to be doing, and I will post the solutions to the other questions for you. Okay, so the notes will be posted, but obviously try doing the questions that are not circled on your own. So the homework is everything that's not circled essentially, okay, which isn't a lot because you don't have to do any calculations here, okay? You kind of just need to understand how this works. Okay, so let's do question one. So when the points are given to you, right, domain has to do with your x values, okay? So the domain here. Okay, because so I'm just gonna put D for domain is equals to because there's a finite number of x values, right? So I'm gonna have to list them manually. Okay, so so you have to open a squiggly bracket, so it's kind of hard to draw. I my left bracket actually looks nice. The right one isn't that great, and I can kind of do that really good in with the smartboard, but with this not so great, I guess. So the squiggly bracket kind of looks like this. Okay. Again, uh, I'm not very good at drawing it. Okay. So I think I kind of got it. Okay. So that's what the squiggly bracket kind of looks like, and all you have to do is list all your x values. So remember, when you have a coordinate, the first point is in your coordinate will always be x and the second one is y. Okay, so because domain has to do with your x values, right? This domain has to do with your x values. You're gonna list them in increasing order, okay? Because again, domain goes from the minimum x value to the maximum x value. In this case, they are discrete, right? So you're gonna start off with -2, right, from here, -2, and then comma 1. Next one is 0, and then I think that's -1. I'm kind of, my bracket is hiding that negative sign. So let me just erase this a little just to see. Yeah, it's -1. Okay. So -1, 0, and then next one is 1, and then 2. Okay. And these numbers should not be repeating themselves. Because remember, if they are repeating, then you no longer have a function, right? A function, in a function, an x value can only have, can exactly have one y value associated to it, right? So in this case, think of the source set as your x, this is as your y. So your domain again is D for domain is equals to squiggly brackets 4, 7, and 8. Okay. Again, this is a function because um, domain and range only makes sense when we're talking about functions. Okay, it doesn't make any sense with the relation, and this picture kind of tells you why it is a function, right? Because you can see each x value over here has exactly one y value associated to it. Okay, so it is a function if you're wondering why. And again, the domain range business only applies to functions anyway. Okay, so you guys can do 2 and 4. Now I'm going to do question 5. So when you have a function, right? So this was just a set, and when you have a set, it's really easy. All you have to do is just essentially list your x values in increasing order. But when you have a function, right? When you have a function, then there's infinitely many possibilities. Okay, so how do you answer a question like this? Remember, always start with your minimum value. Okay, so x kind of like goes in between, and then start with your minimum value, and then x, and then it has to be less than. So the minimum value over here, right? My minimum x value is this 2. So it's 2, but my function is actually attaining this value, right? If you kind of like, if you can zoom in, which I think I will, right? It actually touches this value over here. Okay, so it touches it. Because it's touching it, I'm going to zoom out. My minimum value is 2. Because it's touching it, I have to put this equal sign. Okay, so x can X has to be greater than 2 or equal to 2, right? So there's no problem. And now I don't really have a maximum value, right? Because look, I'm starting over here and then I'm moving in this direction, but there is no maximum because, my function isn't stopping over here. I don't really have a dot, which means that this is going on forever and ever and ever. Okay, so it's less than infinity, right? But when you have something like this, right? When you have something like this, then you can just not put the infinity, right? So I'm just gonna put this for you just to show you that there is no maximum. But a better way of writing this, right? So I'm just gonna put an arrow. A better way of writing this is x has to be greater than or equals to 2. Okay, so it's what I have over here. X is greater than. You see the wider part of this inequality, right? The mouth of the alligator, if you want, is facing the x, which is what I have over here. Okay, so this would be the best way of writing it out. Okay, um, especially if you don't have a maximum. Okay, so now let's do this one. Okay, I'm gonna put x. Okay, and then there's a minimum, and then there's a maximum. But in this case, you see, there's no dot, so this function doesn't stop. It actually goes on forever and ever and ever. It's the same thing over here. So my minimum is negative infinity. My maximum is positive infinity, right? So if you don't have to put the plus sign for infinity, but if you want, you could, right? You can say positive infinity, or you could just say infinity, which automatically means it's positive. Now, if something like this happens, okay, if something like this happens, a better way to write this is just to say that x belongs to this means element, x belongs to, it's like a weird looking e, okay, so this is an e to the real numbers, okay. So again, you could put this extra, line over here. That's the proper notation. But if you're just writing it as XER, that's fine. That means that x can take any value. Okay, square root of 2, 1, -1, pi, whatever. All the values are acceptable because you see there is no minimum, right? All the x values are in this case. Okay, so one way of writing, oops, sorry, let me just so one way of writing this is by um, writing it this way. But a better way of writing this is this. Okay, so both of them are acceptable. Same thing over here. Okay, one way of writing this is actually, you know what? Let me do this a little differently. I'm gonna change my eraser to whole. Let me just remove this. Okay. Oops. Okay. So one way of writing this is by using this minimum, right? This is your minimum, and this is your maximum, which always is the case. But because there is no maximum, this would be a better way of doing it. Okay, so this and this, they are equivalent. It's just that what I have on the right side, right, this stuff over here, is much concise, right? So it's a better way of writing it, but both of them are correct. Okay, so let's move on to the next question. Again, when we're talking about domain, we're talking about x values. Okay, so if you look at this function, again, a weird looking function, but you see there is no minimum x value. It starts from here, goes here, isn't really touching this value of 2. This is what we call an asymptote, right? Those dotted lines are what we call asymptotes. But don't worry about that. And again, the x value kind of starts from here and then it goes. So the only value that your function is not taking in this case, okay, the only value that it's not taking, if you look very closely, if you can kind of like zoom in, you'll see that it's getting very close to 2, but it never actually touches 2, okay. And that's true for both this line and this one. Okay, so see, this is the 2 value. Okay, my function is getting very close to 2, but it's not exactly touching. Okay, it cannot touch because that's what an asymptote means. Okay, so how would you answer this question? So let me zoom out for you. So the answer over here is that x can take any value. X can take any value except 2. Okay, so x cannot equals to 2. You see, x can equals to -10, -9, 9.5, whatever, all the negative values, and then 0, and then 1, 1.5, 1.6, 1.7, 1.8, 1.9, 1.999, but not 2. Okay, and same thing over here. Here your x value might be 2.01, 2.1, and then 2.3, 2.4, 2.5, right? So it's increasing, but it cannot be 2, okay? It cannot be 2 because of this dotted line over here, okay? So that's what we call a vertical asymptote. So this is your domain. X is not equal to 2 means X can take any value, pi, whatever you want, as long as it's not 2, okay? So this one's kind of tricky, but I hope it's kind of making sense. Now the next one, very similar to question 9, but here, right here, x cannot, so this is -3, right? This is if you want x is equals to -3, because this is -2, this is -4, so this is -3. Now x, again, because this is an asymptote, right, your function cannot touch this value, okay? But the function, there's nothing on the left hand side of this, right? So remember in the previous function you had something like this, right? You had something going on the left hand side. So there is a minimum in this case. My minimum value is actually -2, okay? Now x cannot equal to -2 because it's not really touching this value, okay? So you cannot put this equal sign here. But there is no maximum, right? There is no maximum, so it's less than positive infinity, right? So a better way of writing this is just to say that x is just greater than -2, okay? So my function is defined, in other words, my function can take all the x values over here, right? As long as they are greater than -2, okay? So all the x values, as long as they're greater than -2, okay? So this would be, both of them are right? This would be a better answer. Okay, so what you have down here would be a better answer because it's much more concise, right? You don't have to include the infinity, but if you do, if you like this notation better, the one on top, right, with a minimum and a maximum, then go for that. But I think this is much more concise. Okay, so remember, when it comes to domain, we're talking about the x values. Now let's talk about the range. Okay, so the only difference is with range, we're gonna focus now on the y values. Okay, y values. So if you have a set, right, then all you have to do is, let's just put R for range. Let me zoom in a little bit so that it's easier for me to write this out. Okay, so squiggly brackets. Now you see this is my x value, right? This is my y value. Now I only have to list the y values in increasing order. Okay, so 4, 5, right? 4 from here, 5, and 6, 7, and then 8. Okay, so 6, 7, 8. So that's my range. Now you guys can do the second question, okay, using the same logic. This one, same thing. Now this is your x, this is your y. So your range will be, again, list them in increasing order. Okay, so 3, 5, and 9. Okay, make sure you're listing it in increasing order. Okay, so again, as you can see, my bracket on the left looks much nicer than the one on the right. And I don't know why that is the case. Okay, it's always like that, even when I use the smartboard. So this one, like, I can do this really nicely, right? This one, as you can see, but the other one I always have trouble with the closing bracket. So just forgive me, I guess, because this is the best that I can do. Okay. So now, again, our focus is shifting from domain to range. So we're gonna do question 5. Okay, so question 5. Now I'm looking at the y values that my function is taking, right? So the minimum y value that my function can take is 3, and then it goes up, and it doesn't stop here because there's no dot. Okay, so that means it's continuing, and it will increase and increase and increase. Okay, so this kind of looks really bad, but basically this is what it should look like. So it's going to go on forever and ever and ever. Okay, so same thing. Okay, your minimum value is 3. But because your function is actually touching this value, right, as you can see, it's actually touching it, you're going to say that your y value, I'm going to zoom out a little bit, right? So your y value has to be greater than or equal to 3, because it does touch your minimum, but there is no maximum, so it has to be less than infinity, right? And again, a better way of writing this, right, I'm just going to put a comma, is just y has to be greater than or equals to 3. Okay, so this is the same thing, okay, but this one is much more concise. So as you can see, right, my y values have to be greater than 3. So all these values will eventually, my function will eventually hit all the values up here. Okay, so it starts from 3, right? So if you want, you can kind of like put a dot over here, right? It starts from 3, and then it goes upwards, and it will go on forever and ever and ever. So you can kind of like draw an arrow over here, okay? So that's your range. Again, focus now is shifting from the x to y, okay? You're not looking at your x values anymore. You're looking at your y. So I'm going to ask you to think about this one, question 6. But again, just to give you a hint, right? So remember that there's no dot, so this function doesn't stop. It's kind of like going forever and ever and ever, and also in this way. Okay, so it seems like there is no minimum y value and there's no minimum x maximum y value, right? So you can kind of think of it as minus infinity y infinity, right? So I guess I'm doing this for you, but a better way of writing this is just y belongs to the real numbers, okay? And you don't have to put this extra line over here, but that's the correct notation. I'm gonna do it, but if you don't, it's fine, okay? So that's how you would do question 6. Now let's go on to the next page. Okay, so again, you can think about question 7 and 8. I'm gonna focus on question 9 and 10, okay, because these ones are slightly difficult because you have asymptotes, okay? Now let's zoom in a little bit. So question 9, as you can see, right, if I'm looking at my y values, my function is taking all the y values, except for this one, okay? And then if I start from here, it's taking all the y values here. The only value that it's not taking is this one again, okay, -4. So just like the domain question, right, the range for this is that y cannot equals to -4, okay? So this is -4 because you have this asymptote. Okay, so asymptote means that your function will get closer and closer to that value, but it will never touch. Okay, it doesn't matter how small your x gets or how big it gets, it will never touch this value. Okay, and you will see functions like this next year. Okay, they're called rational functions. Um, so yeah, I mean, if you have any questions about rational functions, if you're interested and would like to know what the equation looks like, I can go over it, during my office hours, but that's not part of your curriculum, okay? So anyway, so as you can see, my function takes all the y values, right, except for -4, okay? Now in this case, it's kind of tricky because the function isn't drawn properly. How your function should have been drawn is technically when you have an asymptote like this should have continued. Okay, so I'm going to fix this for you. So this continues, it never touches it, but it continues. Okay, so as you can see, there is no minimum. Okay, there is no minimum, and if you think about it, your function doesn't even stop here because there's no dot to stop this, so it's continuing in this direction as well. Okay, so there is no minimum, right? So minus infinity, y has to be greater than minus infinity because there's no minimum. And this picture hopefully, illustrates the idea that there is no maximum, right? So there is no maximum. So that means that y again belongs to the set of real numbers. Okay, so it could be anything. It could be, whole numbers, negative numbers, um, square root of 2, pi. It's going to take all the values eventually, right? Because there is no minimum, right? So it's going down this way, but it's also going up very slowly, but it is going up. So it will eventually hit all the y values and a positive or negative. Okay, so I hope this is kind of making sense. Okay, if not, let me know. Send me an email. And if you want, I can yeah, maybe do a few other questions that I've chosen intentionally not to do because I want you to practice, right? And obviously, because your test is on Thursday, I will be holding office hours on Wednesday. So you can also join me on Wednesday during class time, and I will help you. Okay, so your homework is just to finish the questions that I haven't done. Okay, so 7 and 8 over here, and then you were supposed to do question 6, but I did that for you. So 4, 2, and then here 8, 7, and 8 again, and then yeah, there's not that many, right? So 2, 4. So whatever questions I wasn't able to do, please do those ones. I'm gonna be sending you the blank notes and the filled in ones with the solution. Okay, so that is it, guys. That is it for this week. If you have any questions, send me an email or come see me on Wednesday. Okay. So have a nice week. And hopefully um, the test will not be too difficult for you. Okay, so take care, guys.